recorded, and the recording will be placed on the YouTube channel. If you're not comfortable with that, you could go ahead and drop now. Also, the call is attended by Microsoft guests and partners, along with the Microsoft employees. So welcome everyone. So today's topic is LUIS, which is the NLP offering from Microsoft, Natural Language Understanding. Our agenda at a high level. Please tell me if you could, guys, if you can't hear me well or you don't see the screen. I'm sharing the screen. Please let me know. But otherwise, I'm assuming things are well.
See you
I
and
hope.
can hear you.
All right, awesome. Thank you. So at the high level, the agenda today, of course, we are talking about LUIS, but I would like us. LUIS is part of the Azure Cognitive Services. So let's have a quick look at the cognitive services first, just so we could see where LUIS fits in the big picture. Then we'll look at some common use cases where you would meet LUIS, some important terminology that would help us during the demo. Let's get started. My name is Ala Tadmouri. I'm a cloud solutions architect at Microsoft. And
yeah, if you don't mind, can you go on the presenter mode? Thanks.
Tell me what you mean by presenter mode.
Full screen.
Oh, you mean in the PowerPoint here?
Yep.
Sure. Yeah.
Thanks.
Yeah, sure. Thanks for letting me know. Yeah, that's much clearer, I bet. All right. So we were here. Oh, these have some builds of them. Okay, no worries. So what is Azure Cognitive Services? This is a set of artificial intelligence services across multiple domains that help developers build intelligence into their apps. That's at the high level. You could see the categories here: vision, speech, language. LUIS fits here under language, but you could see that there are multiple languages. Here from the official definition by Microsoft for Azure Cognitive Services, you see that it's cloud-based. I'm not going to go through the entire thing, but I want to highlight that it has REST APIs and client SDKs to help you build intelligence into your applications. And the second point here, that you could build these features without having artificial intelligence or data science skills. So from that, basically, Microsoft is telling us that these services were built from ground up with the developer in mind. So it's not an afterthought, to build intelligence into the applications. Those were meant for developers in the first place. So we'll put that theory to test today. We'll see and see the demo, see these the REST APIs, we'll see the SDK, we'll see how easy to integrate that with our applications. Last slide on the cognitive services. Under the categories, you will see here, like under vision, you will see the face, for example, recognition. You will see the emotion, allows you to or sentiment of a face, for example. You could see you're probably accustomed with a lot of these services, but you could see LUIS is part of the language, and you could see in the big picture is only one service out of many here. And you could imagine with any full-fledged application, you would use a combination of these services, not only one of them. For example, you could use speech recognition here for somebody to speak to your application, let's say, and then that speech recognition would translate that into a text. You could feed it into a spell check to spell check it, and then you could feed it into LUIS, so you have more accurate prediction. So what is the LUIS we talked about? It's the language and natural language understanding. So basically, you have some text, you feed it into LUIS, and LUIS output would be the meaning prediction of the text you just said or inputted to Lewis. So this meaning prediction is in form of JSON. I know it's too small. I don't need you to read it now. I'm going to show you another slide for the JSON, but I want you to know that the meaning prediction is in the form of JSON. So you could basically, for example, have the text input as like, how's the weather looks like today, or how does it look like today outside, for example. You don't need to say the words themselves. And then Lewis would predict that the user is looking for the weather forecast. So in Lewis, we call this, I'm going to go to the terminology, but now that we are at this slide, it's easier to see. In Lewis, we call this input text the utterance, and the output of Lewis is the intention or the intent. So let's go here. So as I mentioned, the utterance is just the user input, simply put, and the intent is the output. That's the easiest way to see them. Yeah. Is there any question? Anybody? Okay. So I have a link here for the full glossary, but those four I wanted to highlight because they are important if you want to read the documentation, or for actually even for our demo today. Let's start. Also, I don't want to miss this. The NLP. We know that Lewis is part of or a family of NLP, natural language processing. This might be like painfully obvious, natural here, but I think it's a key word. Let's make sure we understand what is natural in this context. I think it's key to understanding Lewis. So natural just means here like natural language means the everyday language that we use. For example, if you have a device that could control the lighting of the room, could turn the light on and off. It could accept two inputs here, like turn the light on and off. If this device only understands turn the light on and off, it's not an NLP. It should be, for it to be an NLP, it should understand more of day-to-day language. For example, you could say, I wish the room is more lit, and then your device should be able to understand that what you intended is really that you wanted the light to turn on. So if we understand that you know that this is not a text match, it's beyond that. There's the artificial intelligence piece of it that's trying to make sense of the text to figure out the intent of the user. So those three we covered. Entities is the easiest way to understand it, is that it adds context to the user input. So for example, you could ask, how's the weather? But that's very like general. You could add to it, how's the weather today? Or how's the weather near me? How's the weather in New York, for example? So those New York or near me or today, those are all are referred to as entities in Lewis, and those provide context to your inquiry, let's say. You could again see the full glossary here. There are more, but I think if we are on the same page on those terms, I think we should be good for the most part. All right. So common use cases of Lewis, you don't think this should come as a surprise. Chatbot is a very popular example when in websites where you could see like your a digital assistant or something. This is you could imagine it's powered by Lewis in the back end if it's an Azure, let's say, hosted website or something. Also controlling IoT devices, Cortana, for example, stuff like that. Those all powered by or could be powered by Lewis. I promised we'll come back to the JSON. So the output of Lewis, as we discussed, is the prediction of what the meaning of the sentence that the user uttered. If we stick to what Lewis terminology. So here the query order a large pizza. What I'm going to show you in the demo is a small application about pizza. That's what's in the Microsoft documentation. So I stuck to that. So let's say a user, we are building an application that responsible for placing orders for pizza. The query, let's say a user says, order a large pizza, and then Lewis would take that query as the input, and the output of it would be this prediction. It would predict that the user is looking to order a pizza, and it also gives the accuracy. And this is a score from 0 to 1. 0.8 being closer to 1, meaning it's definitive to close to 0.8 is quite a good score that you could depend on to or actually that's up to the requirements. I cannot say that, but yeah, this is a pretty high score for that. Lewis is predicting that the user wants to order a pizza. There are other intents that the application defined. For example, greetings, you say hi and hello and all those. It's predicted like pretty much sure that the user didn't want to say hi when she or he said order a large pizza. Also, there are some other intents. In the entities, you remember those like large, small, or what city you are in, or those the entities that provide context more to the utterance. Since here in the utterance or in the query order a large pizza, it's figured that the size of the pizza should be large. The user is trying to place a large size pizza. So you could have, I'm going to show you how you could identify some entities. With that, I'm ready to jump into a demo, show you all of that in practice. I think it would clarify the concepts that we talked about. If you have questions so far, please go ahead and ask. Otherwise, let's go to the Azure portal. This is the tutorial that I told you about the Azure Pizza. We'll come back to it now. We need to create the app, so I'll go to the Azure portal, show you the resource creation. Quick, there's nothing special actually about it, but let's have a quick. This is, I created here a demo. Let's create a new one. Let's look for Lewis. And yes, we want the language understanding. I'm gonna choose the language understanding offering and create that resource. So in Lewis there, when you create Lewis here from the Azure portal, it prompts you or gives you the option to create the two resources that makes a complete Lewis application. If you could otherwise create Lewis from the Lewis portal where you build the model. I'm going to show you the creation from here, but if you create it from Lewis, you only create the authoring and then but not the prediction. Here in Azure, you could create them both at the same time. The authoring is where you build the AI model and train it and publish it. The prediction is where you run the queries of this published model. The simplest, but you could read more about these two types. Let's create a new resource group. RG Lewis demo 02. Right here, the region where I want to deploy this, I'll stick to the US here. There's only one pricing tier for the authoring, it's the free tier. For the prediction resource, I'll put it on the same region, West US here, same region as my authoring resource. Here you could see that we have two pricing tiers. The free version allows you for 10K calls per month, and then you have the standard paid version. I stick to the free. All right, let's go ahead and create them. Okay, creation is done. So the resources here in the Azure portal is where you control, as you saw, the pricing tier. You could scale, and you could see the access keys to these resources. You could manage access, but to build and deploy the model, you would want to go to the Lewis.ai. It's sign in here. The resources that I created here should pop up now, or should show in Lewis AI. Those are that already created. I could change that. This is my subscription, and then this is the one that we just created, the demo 2. Let's select the. You can see managed identities disabled. If you want to enable it, you would need to go to the Azure portal and enable it. But there's need that it has managed identity already supported there. Okay, let's create a new app. This is the pizza app. Culture English works prediction resource. Could can select the prediction resource that we just created. Create an app. Okay, some tutorial. It's fine. Okay, so now we want this app to be able to understand the pizza domain, let's say, like, so order a pizza, put cheese topping, etc. All what you would expect from somebody coming to an app to order a pizza. So let's create some intents. Order pizza is probably the first intent of a user. You see, are you with me here? Like on the intent. The intent is what the user, what Lewis would understand that this is what the user intended to do. So now you could say the utterance would be, give me a pizza, and then Lewis would understand that to be the user is intended to order a pizza. So this is the intent, order a pizza, and then as many utterances as I add and train the model as intelligent Lewis, this pizza app would be. For example, the most straightforward to say, of course, order a pizza. You would expect somebody to say order a pizza if they want to order a pizza, but also like give me a small pizza. Actually, I have this here open, so I could copy all the utterances. But here I'm just adding what I expect users would say to call into ordering a pizza, or to order a pizza. So I could add all these utterances here. Let's add them quickly. Can I get a small pizza with onion? Okay, works. Delivery for a small pepperoni pizza. Pick up a cheese with a cheddar cheese. Order a pizza. I pretty much like the first one that I inputted. So we have so now we have a set of utterances. All we are telling Lewis that any of these utterances or any similar utterance, because it's basically what we're going to train the model, and Lewis would put the artificial intelligence on top of this to understand all the variations of these utterances. and what should be able to then have any similar utterance tell us that the user wants to order a pizza. Let's train this model based on these utterances. And let's publish this. I publish it to production. Okay, so now Lewis gave us this endpoint that we could take here. I put it on incognito. You could see that in the URL, there's the subscription key, the key to the app, etc. Only your query you should all what it requires. So let's put the most direct way, order a pizza. Sure enough, the top intent that Lewis identified is order a pizza, and it's quite like definitive that what I wanted from this query is order a pizza. But that, of course, was very straightforward. I just put almost like a text match here. So let's do something more interesting. I don't know. Hungry and want to eat. Let's see if that's still like, although you see I didn't put any text that's similar to any of the utterances in my application, but still Lewis was able to predict that what I wanted to do is order a pizza. So that you could see that it's just an API endpoint and wrapped up so many, like, coolness here of AI. We could, of course, I added only one utterance, but you could, or only one intent, order a pizza. You could add another intent. Let's say, I don't know, order a drink in my pizza app. Actually, in just in favor of time, we could come back and add utterances, but I want to show you the entities here. Like if when I put here order a small pizza or pizza, the entities is still empty, although like small. We wanted to know what size of pizza the user wants to place an order for, but Lewis at this point doesn't yet understand that. So we need to identify that we have entities, or we are looking also for more context from the user. So I'm gonna add an entity called size. I'm gonna make it of type list. You could make it of type machine learn, so you don't need to put all the values necessarily exactly, but I'm gonna go with the list now. We have only large, medium, and small in our example. So let's make the simplest here. So large and medium and small. I'd like also synonyms to these, as like small is S, medium, etc. But you got the point. I'll train the model again. Did I leave anything? I doubt it's because I didn't fill this. The train should be. You know, when I go to the intents now, it's able, it automatically detected that those utterances that I put there, they have the sizes there. So now I should be able to train the model. I'm not sure what I missed here. Maybe I didn't save something, but hey, that's why you have always I'm gonna go to the one that I created previously, so I don't put you through this. Let's try it some more. I don't know. Train is not showing some intents. Okay, I missed that error. What did it say? But anyway, now it's showing. So let's train the model again to see if it understands the entities. Oh my God, only 4 minutes left. I wanted to show you the code. So let's go quickly and have order a small pizza, run it again. It doesn't understand it yet. It might take a minute. Actually, it's because I didn't publish. So I needed to train the model, publish it with the new entities. And now it shows the size of the pizza. It was able to detect the size. Now, if I selected a machine learning instead of the list, if I put order a tiny pizza, for example, it should be able to understand that to mean small. I want to go to the code demo very quick. I set up here the application. Of course, please do not encode or hard code your keys like these. The location of those values are the key vault. I'm gonna delete these resources after the demo, but I wanted to simplify it as much as possible. You could see here, I want a small pizza. This is basically the same query that I put in the query string. Let's run it quickly. You would expect to see the same JSON here. Let's go quickly. I want to highlight, you see this Lewis runtime client. Of course, you don't want to new it like this. You need some dependency injection. Beside the point, what I want to take from this, you see, we are talking about Lewis today, but as we talked, Lewis is part of Azure Cognitive Services. Take this code example as an example of the entire cognitive services. You would expect, even if we are not talking Lewis, if we are talking some other like Vision, let's say, or something, you would still expect to see a client that's instantiated with credentials and an endpoint. So if you train your eye to look into this consistency, you find that Azure is so much easier to learn, because now it's not an like isolated case that this is the way you do you program against Lewis. It's actually pretty much consistent across Azure Cognitive Services. You always have a client you instantiate it this way, and then also let me run here this quickly. Although the output was in JSON, of course, it's because I serialized it. But here, if you look at the prediction, you will see that this is a C# class that you could deal with it as a C# class. So, and here, the last thing you probably have time to mention is that Lewis journey ends by the time it gives you the meaning prediction. So here, what you have, this is the end of Lewis journey. Now you have the user intent, you have the size, let's say in our case for the pizza. Now it's up to you to complete the journey for placing the order. So Lewis gives you the intent, gives you the score of how sure it is, and then it's up to you to continue with that, to build the application or feed it to another service. And as you could see, it's you could do that easily here with having this pretty much like the job is done with the SDK providing all these capabilities built in. You don't need to parse the JSON or do any of that stuff. Sorry, we run out of time. And the slides that I have here, and the last one, I have the full code where I got this code from. There's not only the prediction, but also how you build the entire application and add utterances from C#. There's also support for other languages. You could look at these resources. You could clone the source that I showed you from my GitHub here. That's it for today. Unfortunately, there's a lot to talk. Don't be intimidated by artificial intelligence. If you are not an expert of artificial intelligence, you could bring the power of artificial intelligence to your applications. with Azure Cognitive Services. So go ahead and try them. It's the best way to learn. Have a great day, guys.